We're using that. Okay, so if you go into Google Drive, there's some new files in there, but I wanted to show you in particular. So if you go in there, you should see like course information. That's where the syllabus is. We know that. Old exams is now there. So in there, I've put the past maybe 2 semesters of my exams, and then the past 2 semesters of the departmental exams for Math 156. So Math 156 has changed over the past couple of years. It used to be that everybody gave their own exams. And then about a year and a half ago, it became where the department, kind of somebody in the department wrote the exams for the sections. And that's still the way it is this semester. So like if you go into departmental exams, you should see files for last fall and last spring, not spring 2020. Spring 2020 was a little weird because the COVID thing happened halfway through the semester. So if you guys want those exams, I can post them. But after exam 2, it was a lot different from what you guys will have as far as the material covered. But anyway, you have the exams and then you have worked out solutions. And in these PDFs, it's all 4 exams in there. The final's not there, but all 4 exams are there. So if you go in, it's exam 1, 2, 3, and 4, and the coverage is mostly the same. Exam 1, a lot of it would be the same as exam 1 is now, but you might see a question where maybe we were a little bit farther ahead one semester, or maybe we didn't get as far and you need to go into exam 2. So you kind of can look at that and figure that out, or if you're not sure, let me know and we can look at that. But those are the departmental exams. In 2019, I was not one of the ones writing the departmental exam, so just so you know that. And then if you go into the Doug's exams, then that would have been 2018, so that was when I was writing my own exams for my own sections. But again, you have all 4 exams for fall and spring, and you have the solutions to those where I've worked out full worked out solutions. And now, even though technically this semester they are departmental exams, I am the one that's writing them for the department. So me and Ivana kind of write them together. It's going to be different because it's not a paper exam, but if it is something you take into consideration, like who's writing the exam, I am the main one writing your exam this semester. So you can see what I thought was important 2 years ago. That has not changed much. I still think that's what's important about Calc 2. So you can kind of see what's in there and see how I ran those exams, and then you can see worked out solutions. So I'm not going to collect any of that, but you definitely are welcome to use that to study. Again, it's all 4 exams for the semester. We don't typically release finals, but the regular exams are there. All right, any questions about that? You guys good? Okay, and then I just sent an email. Is that true? Did you guys just get an email from me like maybe 5-10 minutes ago? Okay, yeah, so like right before I signed on here, I sent you guys a big email about this week. In it, it's talking about what's coming up for this week. So I just kind of wanted to give an overview of what we're going to be doing this week. So you guys do have your first test on Thursday. You're going to have the exam's basically going to cover Unit 1 that we've covered so far, which is basic integration and U substitution. That's what we started with. And then it's going to cover most of Unit 2. So Unit 2 is applications of integrals. And so, you have the graphing review, which was completely optional. And then you've got volume and area that we've been covering a ton about. So we are kind of through the volume. We're going to do some more with volume today. But if you go in there, you see volume and area 1. That's the last assignment that you had to hand in on CrowdMark. So that's the last one that's due today. Volume and area 2 is another set of volume area problems, obviously. And then volume and area 3 is another set of problems that you can do to practice. I would recommend that you do both. I don't have the solutions available to volume and area 3, but those are ones that we can work together in exam review sessions and things like that, or office hours or whatever you guys want to do. But those are more practice problems for volume and area. If you've read that email already, if not, you can read it after class or whatever. I'm not going to collect any of the homework for this week so that you can pace yourself for the exam. So you can decide how you want to study and whether you want to do all of these or whether it's really better for you to practice U substitution. That can be up to you. But anyway, volume and area 2, volume and area 3 kind of correspond to what we've already been doing and what we're going to be doing today. And then more volume is something we're going to start talking about at the end of class today if we have time. And if not, that's going to be tomorrow's topic. But that is actually different from what we've been doing. It's still volume, but it is a little bit different. And so we're going to look at those problems either at the end of class today or during class tomorrow, depending on time. But you have solutions to that as well. we'll actually be working a good bit of this handout together, and then you can finish the parts that we don't do outside of class. So that will cover tomorrow's lecture and maybe the end of today's lecture. That'll also be where the test cuts off. So the test will cut off after that. Does that make sense, everybody? So we're going to cover through all volume and area, and also this kind of more volume stuff, which is when we're talking about volumes of solids, but they're not formed by rotating around a line. So like all the ones that we've done so far have been rotating around a line. We're going to do a little bit more with that today, but all the ones we've done so far have been revolving around a line. At the end of class today, or more likely tomorrow, we're going to talk about ones where they're formed not by rotating around a line, and that's what this topic of more volume is. So we're going to have that on the exam, and we should be done, unless it takes way longer than I plan. We should be done with that tomorrow. The topic for Wednesday is average value and arc length. So those are actually two different topics, but they take maybe 10 to 20 minutes total to talk about. This isn't a large topic. We won't go through the derivation of the formula. We'll talk about the idea, but there's a worksheet on each of those, average value with the solutions, and then arc length with the solutions. I am, again, not going to collect those. Those two are not on the exam, so I would highly recommend that you do not do them until after the exam. Does that make sense? So normally I would like you to do stuff ahead of time, but this I do not want you to do before the exam. It's not covered. And then actually what we're going to do with Wednesday is Wednesday's lecture topic officially will be average value and arc length. But rather than do a live lecture on that, I'm going to send you pre-made videos on those. One is only like 10 minutes and one of them is about 5 or 6 minutes. So it's like less than 20 minutes total of videos. And then you have these two worksheets, and you can watch them on your own time or whenever you want to schedule it in. But it's officially Wednesday's topic. I think you're better off studying for the exam Wednesday. Does that make sense? So you can watch them anytime you want between now and exam 2, when that's the first time they'd actually show up on a test. Does everybody understand that? I think that's better for you guys. If you'd really rather sit and do it as a live lecture, I'm happy to run one at some point, but I think it's better for you Wednesday when we're sitting here. We'll run this time, and that'll be one of your 2 review sessions. We'll do a review session at 12:30 on Wednesday, and then we'll also do a review session Wednesday night. Does that sound good to everybody? Any questions so far? You can put them in chat, or you can just unmute yourself and ask. Let me pull up chat. It always disappears when I go into shared screen, but I've got chat up. So if you guys do have any questions, I want to talk about some examples today, and then if we have time, we'll start on the solids that are not rotations. But any questions? No questions at all. All right. All right. So the first test is Thursday.
I have a question.
Sure. What's your question?
Is there going to be any class on Thursday?
No. So Thursday, actually, I'll be relatively unavailable Thursday. I'll be available if you have like technical questions, but I actually won't be available much to help with math, because it's not fair once kind of somebody's taken the test. You know what I mean? So, so you really, any questions you have for the test need to be on Wednesday. If there's a technical question about how to access something, of course you can ask that. But Thursday to ask like how to run a question, that actually can't happen on Thursday because it's technically during the exam. You guys will be able to take the test anytime on Thursday. So you can start as early as 12:01 a.m. and you have to finish by midnight. But when you start the test, you get 90 minutes. And so, you know, you need to start by 10 p.m. just to be safe that you submit it. But if you choose to start at like 8 a.m., then it's going to cut you off at 9:30. Does that make sense to everybody? Okay. Any other? And so anyway, I'd like to be there to answer questions on Thursday. It's not fair once somebody has seen the test. You know, it's going to be different for everybody, but still, once the test is out, can't do that. Or I can't really answer questions. Okay, is it on CrowdMark? Shelly, we're still actually finalizing that, so that's why you're getting the big email about the test tomorrow. It's likely that it will be all on WebAssign, and that some of the questions will require photo uploads to WebAssign. If that works, so I'm testing that this afternoon. If it works well to photo upload to WebAssign for certain questions, then we will have it all on WebAssign. If that does not work, there will be a WebAssign part and a CrowdMark part. Does that make sense? But we're still testing it. We've never run a test where you upload photos to WebAssign. So I've got to test that. If that is reasonably decent, then we will do it that way, because I'd rather you guys just have it all on WebAssign and just be done with it. Okay, other questions? You guys good? but please ask, because this is the stuff we do need to figure out. Okay. All right. So let me get into my Notability app, and then I wanted to run through a problem all the way. Okay. Oh, my bad. Yeah, so a couple more questions in chat. So we can have handwritten notes. Yes, you can have handwritten notes. So you are welcome to have the PDFs printed out. You can use anything you want from class. So if you want to use those formula sheets, that's fine. They have to be hard copy form. So if you don't have a printer, I'm sorry, I don't have a way to send them to you. But if you want to hand write them, that's fine. Or if you want to print them out, if you have access to a printer and you want to print it, that's completely fine too. Does that make sense, everybody? So it's just everything has to be in hard copy format. You cannot pull up stuff on your computer. You cannot be using your phone. So nothing electronic. No calculators. You cannot go to Mathway. You can't use that type of stuff. But anything handwritten is fine. And you may have solutions as long as they represent kind of the methods we're using in class. So one thing I said, I think in one of the days last week is like, if you are working with Wolfram Alpha or you're working with Mathway when you're doing the homework, you're allowed to do that. That's completely fine. But if the method they present is completely different from what we're doing in class, that's not allowed on the exam. Does that make sense to everybody? Okay, and then now small variations, that's okay. So like if the way you show U sub is a little different from the way I show U sub, that's fine. But if you're using a double integral to calculate volume, we don't know what that is in this class. And so if Wolfram is showing that or some website showing that, that is not allowed on the exam. Does that make sense to everybody? Everybody understand that? So it's got to be more or less our methods when you're doing this. Okay, and then the next question, so I'm just gonna go down the chat. The next question, is it open all day? It is, so you can start as early as 12:01 a.m. I would then say you have to start by 10 p.m., but just once you open it, it's no longer open all day for you. Once you open it, it starts your time limit, and then you have to submit before your time limit's up. Does that make sense to everybody? Okay, and the test is gonna be designed to be done in about an hour or an hour and 10 minutes, so 60 to 70-minute test, but you're going to be allowed 90 minutes to allow for any technical issues or to allow you to have some time to take a picture of your work. You will have to upload pictures of your written work. Somebody asked, will it be recorded? I'm not sure what you were referring to. I'm sure it made sense like right when you texted it because I was probably saying something, but I don't know what you're talking about as far as recording. So if you want to re-ask that question, that's fine. Is there a limit to how many handwritten notes? No, Andrew, if you want to have 1,000 pages of handwritten notes, that's completely fine with me. It does not have to just be on one sheet of paper. And I think I saw that in an email on my phone and figured I'd talk about it now. So I'm glad you reminded me. Yeah, so you can have as much, it's not like you have to fit it into a note card. You can have examples worked out. You can have whatever you want. Just get organized because you're not going to have so much time that you're going to be able to go find the exact problem. You know what I mean? So like you definitely want to get it organized and like have the notes that are important first and things like that. Spend time this week getting that stuff together. Madeline asked how many questions will it be? If I knew, I would tell you. I don't know. The test is not finished. When I finish it, I will let you know. Is that fair enough? Just keep asking that, but I don't know. Proctored, not completely, Andrew. So there will be some level of security, like you'll probably have to take a picture of yourself or something like that, but you will not be like videoed the entire time is what it's looking like, and those details will be tomorrow. Okay, so is the exam recorded? Like, are you being recorded taking the exam? Probably not. Okay, so now if it's clear that there's a lot of cheating on this exam, then when we go to exam 2, that will likely change. So don't cheat, and then we'll hopefully, I'd rather you guys not have to be recorded every time. Like I said, you'll probably have to do some sort of ID check, so you'll probably have to prove that it's you taking the exam, but you probably will not be recorded the whole time, and then that may be revisited before exam 2 if there's a lot of cheating issues. Does that make sense to everybody? Is that fair? Okay, Tyler, how do you get to the PDFs? Get Google Drive. So you have a shared drive that's shared with your mix. Google Drive is free through any cell phone, basically, or any iPad, and there are apps for pretty much any computer. But it's called Google Drive, and you can go to drive.google.com, drive.google.com. I'll type that in the chat. Man, I'm on all caps. I don't want to scream it. Drive.google.com, and that's where you go just from a browser to get into that. And if you log in using your Mix Gmail, I have shared this folder with you guys called Math 156 Fall 2020 Doug, I think, something like yeah, Math 156 Fall 2020 Doug, that. So you have access to that whole thing, and man, that's where the homework is. So make sure you get in there too. But yeah, you can download apps. Like I'm using a MacBook right now, and I have the app on my MacBook, and I can just access it. It's kind of like Dropbox or OneDrive, but it's Google's, and it's free. So anyway, you get to all that stuff. Any other questions? And Abigail, when you're asking is the exam recorded, is that what you meant? Like, are you going to be filmed taking it? Yeah, I think that's what you meant. So no, I hope we don't have to do that. All right. Other questions? Any other questions? You're welcome to ask. All right. Okay. And like I said, we'll talk. You'll get like the official rule sheet tomorrow. It'll be really scary, and like, if you cheat, this is what happens and all that. So probably better to talk like this anyway. But you'll get that tomorrow from me. And then Thursday you'll actually take it. Wednesday we will hold 2 review sessions. So one of them will be during our normal class time, so at 12:30, and then we'll figure out a time Wednesday night where we'll hold 2 separate review sessions. Those will be question answer. The one during class will be open only to my students, but the one at night will be open to anyone in Calc 2. Actually, the one in class may be open to anyone in Calc 2 too. We'll see. But anyway, I'll hold 2, and that'll be me, not a TA, holding those review sessions. So the TAs are having their half-hour sessions with you guys this week. They can review with you too. They have some old exams they can look at. Those we'll talk more about those meetings for next week, because that's when they'll start being like actually required. But this week they're just kind of helping you guys. Any other questions? We're all good? Okay. All right. So I want to go through a problem. All right. And now we're seeing my iPad. Is that correct? White screen. Everybody seeing that? All right. Cool. Okay. So I want us to consider. Okay, so I actually want to start with this. And I want to give you guys a minute to get a good picture of that region. So remember last week we were talking about how based on the description of the region alone, you should figure out what it looks like. You should figure out all the boundaries, and you should figure out probably the best way to use a rectangle. So whether you should use a rectangle that goes up and down with the base dx, or left to right with base dy. So see if you guys can get that set up, and then we'll check it together in about a minute. Need to add one more curve. Add an x equals 0 is one of the boundaries there. My fault. Give me just a few more seconds, then we'll draw it together. Okay, so y equals e to the x plus 3 is the graph y equals e to the x, but shifted up 3. E to the x has a y-intercept of 0, 1, but shifting up 3 puts it to 0, 4. Y equals 3 is a horizontal line down here. So that's at 3 as well. And then x equals 0 is the y-axis, and that's what I forgot to put in there, my fault. And then x equals 2 is a vertical line over here. And so now, looking at that region, we want to get all of the boundaries. So there's not like formal equations to solve to find the intersections, but like this is clearly 0, 3 on the bottom left, and this is 0, 4 on the top left. And then, okay, we can pretty quickly figure out, since this x is 2, this is the point 2, 3, which means my picture's for sure not to scale, but that's okay because we want to look at this overlap. And then this point is x equals 2, and now y is going to equal e squared. E squared plus 3, my fault. E squared plus 3, and e squared is like 2.7 squared, so maybe a little less than 9, or maybe 8 or 9, somewhere in there. And so then you add 3, and it's like 11 or 12, in that ballpark. And again, not to scale, but the point is to kind of look at this overlapping region. So this is the region we're looking at. Any questions on how to get that diagram? We good? Okay, and so now we're going to draw a rectangle on there, and I'm going to choose for the rectangle to go up and down with base dx, because this way the top boundary is always along this curve, the bottom boundary is always along this horizontal line. If I were to go left to right, the right boundary would always be the same, but the left boundary would change, and that's what we'd like to avoid. Because it's then dx, we want everything solved for in terms of x, so solve everything for y, and we've got the main curve that we're talking about, e to the x plus 3, we've got that solved for the right way. All right, any questions so far? You guys good? Okay. All right, so all of that's based on the region, and now let's say the question is find the volume of the solid formed when the region is revolved about y equals 1. Okay, so we'll find the volume of the solid form when the region is revolved about y equals 1. And so what I'd actually like you to do is go ahead and set that up. And this time we are going to take the time to evaluate the integral. But I'm going to give you a few seconds to try to set it up yourself. Don't worry about evaluating yet. But set it up, and then we'll work it together in just a minute. All right, so y equals 1 is a horizontal line under the region. I'm going to draw it down here. That means we think of the rectangle as being perpendicular to the line. So we're going to think of a large R and a small r, because we're going to use the disk washer method. Big R is the distance from the top of the rectangle to the line because the top of the rectangle happens to be farther away. Make that a little bit neater. So we take the top y minus the bottom y. The top y is e to the x plus 3. The bottom y then is 1, and so we get e to the x plus 2. And so please ask if we're not clear on that. We need to be getting to where we're good at doing that. Is everybody comfortable doing that? Any questions? Okay, and so then small r is the distance from the closer end of the rectangle to that line. So the closer end of the rectangle is the bottom of the rectangle, and the line is here. So again, that's a vertical distance. So it's top y minus bottom y. The top y is always 3. The bottom y is always 1. So then that's 3 minus 1, which is just 2. Everybody good? All right, so then the volume is pi times the integral big R squared minus little r squared. So e to the x plus 2 squared minus little r squared, 2 squared, times the thickness dx. And now we want to add those up for all of the x values in the region. We're using dx. So the smallest x value is 0 because that's the farthest to the left. The largest x value is 2. And so we're going to go from 0 to 2. And our focus has been, and the focus should continue to be, how do we set this integral up? And I do want to just take a minute to go ahead and evaluate one because we have the time. But does anybody have questions to there? Everybody good getting it set up? Okay. All right, so now to evaluate that, you actually need to expand this. So what we're going to do to evaluate it is we're going to go, okay, pi integral 0 to 2, and then I'm going to go e to the x squared is e to the 2x plus 4 e to the x plus 4, and then minus 4 dx. And the algebra for that is that I'm doing e to the x plus 2 times e to the x plus 2, and I'm like distributing that. So like those 3 terms are from up here. And does everybody follow that algebra? You good? All right, and now the plus 4 and minus 4 happens to cancel out. So we get pi times the integral 0 to 2 of e to the 2x plus 4 e to the x dx. And now from there, it's a lot easier to evaluate. Everybody good? Okay, and now the integral of e to the 2x is technically a quick u substitution. And so it's a u substitution where on just that integral, u would be 2x. So du would be 2, which means we're going to get a 2 inside and a 1/2 outside. And if that's something you want to show the work on, you can do that also off to the side. So e to the 2x dx. This is where u is 2x, du is 2 dx. And so we get a 2 inside and a 1/2 outside. And that's where we're that's 1/2 e to the u, but then that's 1/2 e to the 2x plus c. Man, that's supposed to be a 2, sorry. Everybody follow that? That's good. Any questions? Okay, so then we plug in 0 and subtract. So we get pi times, and now it's 1/2 e to the 4th plus 4e squared minus, and then 1/2 e to the 0 plus 4e to the 0. And then that's 1/2 e to the 4th plus 4e squared. Without a calculator, we can't really simplify that. And then minus 1/2 minus 4 because e to the 0 is 1. And now just, I would leave the pi out probably and just make it 1/2 e to the 4th plus 4e squared minus 9/2. And then this would be the answer we would leave on that problem. If you want to distribute the pi, you can. But other than that, there's no need to do anything to that expression. Any questions on that problem? We all good doing that? Okay. All right. So then I want to keep doing a few more setups for this. Erase this for a second. And now, okay. So then see if you guys, and I'll put it up here just so I don't have to erase all that yet. I don't want to erase all that yet. Set up an integral. You know, and then let's just. All right, so about y equals 12 and then x equals -2. And I'm going to erase this and we'll do a few more practice ones, but just set them up this time. We won't worry about evaluating at this point, but give you a minute to try that and then we'll check them together in a second. Okay, so I've got a solution for y equals 12. Is that what we're getting? You guys getting that? Okay. And then for x equals -2, we should be using the shell method. That's over here this time. R of x is x minus -2, which is x plus 2. H of x is e to the x plus 3 minus 3, which is just e to the x. And so the volume is 2 pi integral x plus 2 times e to the x. dx. And that goes again from 0 to 2. All right. Are we getting that? You guys getting that? Okay. Any questions at all so far? Okay. All right. And then I want you to take a minute to set up for number 4. If you're revolving around the x-axis, and number 5, if we're revolving around the y-axis. Okay. So same region, volume if you revolve it around the x-axis and around the y-axis, and then work it together in just a minute. All right, so I put solutions to both of those up. What do you guys think? We getting those?
Isn't the height e to the x?
Is the height e to the x? Yes, for sure. No, sorry. E to the x minus 3. Yep. My fault. So e to the x plus 3 is the top y, the bottom y is 3, so we get e to the x, and we should get x e to the x dx. My fault. Thank you very much. Does that make sense? We good doing that? All right.
I have a question.
Sure. What's your question?
The number 4, we should use the disk.
We should, because the x-axis is down here, right? Whoops. I have it on erase still. Let's do that. The x-axis is down here. And
yeah,
so
yeah.
we think of that as being perpendicular to the x-axis. Does that make sense?
Yeah.
Okay, cool. Other questions? You're good? And yes, I did completely mess up on h of x. H of x should be top y, e to the x plus 3. Bottom y is 3, not 0. And so e to the x plus 3 minus 3 is e to the x. My fault. Any other questions on this? That's pretty good. Okay. Then I think what is better, I think we're going to wait until tomorrow to start on the new stuff where the solid, it's basically doing this dishwasher method, but instead of a circle, the cross section is something else. So it ends up being real easy. Sometimes it's a little bit hard to visualize, but if you're really good at this, then I think it's an easy extension of that, of what we're doing already. If you look at a textbook, they usually do it in the other order. They do what we're going to do tomorrow before any of this. I think it's harder then, but if you're good at these methods, then it's easy to extend what we've done into what we're going to do tomorrow. So that's it for today.